Welcome to MathGPT. Today we'll explore the potential energy function between two electrons. This is a fundamental concept in electrostatics and understanding how charged particles interact. Let's start by understanding what potential energy is. Potential energy is the energy stored in a system due to the position or configuration of objects. For example, when you lift an object against gravity, it gains gravitational potential energy. Similarly, charged particles have electric potential energy due to their electrical interaction. Now, let's look at the formula for the electric potential energy between two charged particles. The potential energy U as a function of separation distance are as given by U of R equals K times Q1 times Q2 divided by R, where K is Coulomb's constant, Q1 and Q2 are the charges of the particles, and R is the distance between them. For the specific case of two electrons, we need to use their charges. Each electron has a charge of negative E, where E is the elementary charge. So for two electrons, Q1 equals negative E, and Q2 equals negative E. Substituting these into our formula, we get U of R equals K times negative E divided by R. Now, let's simplify this expression. When we multiply negative E times negative E, we get positive E squared. So our potential energy function becomes U of R equals K times E squared divided by R. Let's talk about the physical meaning of this formula. Since both electrons have the same negative charge, they repel each other. This means the potential energy is positive, indicating a repulsive interaction. As the distance between the electrons increases, the potential energy decreases, approaching zero at infinite separation. Let's put some numbers into our formula to get a better understanding. We know that Coulomb's constant K equals 8.99 times 10 to the 9 Newton meters squared per Coulomb squared. The elementary charge, E equals 1.602 times 10 to the negative 19 coulombs. Let's calculate the potential energy when two electrons are separated by 1 nanometer, which is 10 to the negative 9 meters. Let's continue our calculation. First, we square the elementary charge. E squared equals 1.602 times 10 to the negative 19 squared, which is approximately 2.567 times 10 to the negative 38 Coulomb squared. Substituting this into our formula, U equals 8.99 times 10 to the 9 times 2.567 times 10 to the negative 38 divided by 10 to the negative 9. After doing the math, we get approximately 2.31 times 10 to the negative 19 joules. This positive value of potential energy confirms that the interaction between the electrons is repulsive. Let's consider what this means. The electrons will naturally move away from each other to decrease their potential energy. The closer they are, the stronger the repulsive force between them. This repulsion is what prevents matter from collapsing in on itself. Understanding electric potential energy is crucial in many areas of physics, from atomic structure to chemical bonding, and even in semiconductor devices. To summarize, the potential energy function between two electrons is U of R equals K times E squared divided by R. This is a positive value indicating repulsion, and it decreases as the distance between the electrons increases. Thank you for watching this explanation of electric potential energy between electrons.